In 3C, we're using Year 11's content of stationary points to identify both the position of those stationary points and also the nature. So there's a few critical parts to this process where we want to include not only the location and its nature, but the steps to get there. So our stationary points will be supported by our sign diagrams from 3B. So to do that, we're going to start by using our calculus of our function, finding the derivative, which would be 6x squared, take 24. We want to be able to identify stationary points. So a definition of a stationary point is that our derivative is equal to 0. So we end up with 0, and at the same time I'm going to take out a common factor. So from that we should get that x squared equals 4 from our null factor law. X must be equal to positive or negative 2. Now again, technology we can always use to support that answer. So I've got that graph here. We can press gsolve max, and that should be at x equals negative 2, gsolve min, and at positive 2. So we know the location from the technology, which has confirmed from our values. Our proof or our working out includes a sign diagram, so we put our sign diagram labelled as f dashed of x. We have negative 2, positive 2. Because we have a visual on the graph, we know that our gradient is positive, negative, positive. So that can be placed into our sign diagram. And then from there we use the x coordinates to identify the y coordinates. So you can substitute negative 2 back into the function, and then again, well, x equals 2 into the function. But because we have our calculator, we've already identified the y coordinate for x equals 2 as negative 17. So 2, negative 17 was one of the stationary points. The other one we can go to finding the max, which was at y equals 47. Now the key terms here are we're looking for its nature. So a local maximum and a local minimum are the terms that we're using. Because the y coordinate here is smaller than that one, I know that this must have been our local minimum, while this one is our local maximum. It is called a local because our graph continues down to negative infinity, so our global maximum and minimums are different. So we can identify these locations. We've stated the position and its nature. We can do the same for part B, where we've got a quartic. The derivative of that function is going to be equal to 4x cubed, take 24x squared. Again, we're trying to find the stationary point, so we equate it to 0, and our common factors are going to be x squared, x take 6. So we have a repeated stationary point and a singular stationary point. So x equals 0. Using our calculator, that would be written as times 2, and x equals 6. So drawing a sign diagram, we have our scale. From there we want to identify which section is positive, which section is negative. So we put in a negative number. This is still going to be positive. This one is going to be negative, so we end up with a negative. When we're looking at stationary points, because it is a repeated root, our stationary point, either side of that should have the same slope. So our prediction should be that this side here is negative between 0 and 6, but we can test that by placing a number in between 0 and 6, such as 1, into our slope function. This will always be positive. Timesing that by a negative number results in a negative. And lastly, putting in a really big number like 10 or bigger, we would get a positive times a positive, giving our positive value. So again, we're trying to identify the location and its nature. So from a negative going into a negative, we can call that a stationary point of inflection. And if we have a negative into a positive, So a downwards into an upward slope, that would be a local minimum. We just need to find those y coordinates for the given function. So we can either substitute it into the top, or we can go back to our technology. X to the 4 take 8x cubed plus 12. At x equals 0, we can find that when we are looking to find the y coordinate, we use ycalc. X equals 0. Our y coordinate would be negative 12, which could have been easily seen from our result. Or we could type in our equation correctly, which would be plus 12. So this, you should now find that is plus 12 there. And the second point we will need to have on the screen to be able to find that location using our calculator. As you can see, if we put in here, it does show it up. We get negative 420. So using technology, stationary point of inflection at 0, 12 and a local minimum at 6, negative 420.